Good day, everyone. Our lesson for today is about arithmetic series, the sum of the terms in an arithmetic sequence. Let us consider the sum of the numbers from 1 to 10. This set of numbers form an arithmetic sequence since there is a common difference of 1. Observe that the sum of the first and the last terms is 11. Followed by the next pair of terms, 2 and 9, which is also 11. 3 and 8 is also 11. 4 and 7 is also 11. And 5 and 6 is also 11, where the total sum is 55. Or we may consider the product between 11, which is the sum of each pair, multiplied by 5, which is the number of pairs. 11 here is the sum of the first and the last terms, and 5 is the total number of terms, which is 10, divided by 2, since we consider them by pair. Therefore, the sum of the first n terms in an arithmetic sequence is the first term plus the last term multiplied by the number of terms divided by 2. We may use the formula a sub n equals a sub 1 plus n minus 1 times d in finding the variables that are missing. From the formula s sub n equals n over 2 times the sum between the first term and the nth term, we may substitute the value of a sub n to this equation. We then have s sub n equals n divided by 2 times a sub 1 plus the value of a sub n, which is a sub 1 plus n minus 1 times d. We then arrive at another equation for the sum of the first n terms of an arithmetic sequence, which is n divided by 2 times 2a sub 1 plus n minus 1 times d. We then have these two equations for the sum of the first n terms in an arithmetic sequence. We may use any of these two depending on the given data from the given problem. Let's have this example. Find the sum of counting numbers from 1 to 50. If we are going to write that down, that is 1, 2, 3, 4, 5 to 50. The first term, therefore, is 1, n is 50, and the last term, that is a sub n, equals 50. Which do you think of these two equations is applicable to this given problem? So the first one is very much applicable since we know the value of n, a sub 1, and a sub n. All you have to do is to substitute the given data to the equation. The sum of the first 50 terms in this arithmetic sequence is equal to 50 divided by 2 times 1 plus 50. One plus 50 is 51, and 51 times 25 is 1,275. Therefore, the sum of the first 50 terms of the counting numbers from 1 to 50 is 1,275. Let's have another example. Find the sum of even numbers between 1 to 100. We may write that as 2, 4, 6, 8 to 100, where a sub 1 is 2, a sub n or the last term is 100, the common difference is 2, and we will be looking for the value of n. Instead of solving for s sub n, we first solve for the value of n using the formula a sub n equals a sub 1 plus n minus 1 times d. To solve for n, we substitute the given value of the variables. N therefore is equal to 50. Since we already know the value of n, a sub 1, a sub n, and d, we may use any of these two equations. For the first equation, all you have to do is to substitute the given variables, and s sub 50 is equal to 2550. If we are going to use the second equation, we do the same procedure. Substitute the value of the variables and solve for s sub 50. And you will still arrive at the same answer, which is 2550. Therefore, the sum of even numbers between 1 to 100 is 2550. That's all for today. Thank you.